You know, another really famous right triangle is one that's built from an equilateral triangle. So if we take an equilateral triangle, that's where all the sides have the same length, which means that all the angles have the same measure. It's equiangular, which means 60, 60, 60. And that's not a right triangle, but if I drop a perpendicular, I make it a right triangle. And in fact, it's easy to see that this is a perpendicular bisector. So if this length, let's say here, is A, that's half of the entire length, which means that this piece right here is going to be 2A. And we've got a little right triangle where this is 60 degrees in measure, and this is half of 60, which means 30. So this is a 30, 60, 90 right triangle. And we can actually find the length of this side if we want by simply using the Pythagorean theorem. Let's see what happens if we try that real fast. So I'm going to call this h for height. Ooh, no, I shouldn't do that because it might sound like hypotenuse. Oh my heavens to Murgatroyd. Okay, let's change that to a letter that looks like height. Watch this, you're going to love this. I'm going to make it W. Look at that, huh? Pretty nice W. There we go. So we know that A squared plus W squared equals the hypotenuse, which would be 4A squared. Now if I solve for W, I subtract A squared from both sides, and so I see W squared equals 3. 4 minus 1 is 3. A squared. Take the positive square root, and I see that W equals the square root of 3 times A. The square root of 3 is the number that's hooked up with the 30, 60, 90 right triangle, just like the square root of 2 is hooked up with the 45, 45, 90. So this W is actually equal to square root of 3A. Now armed with that, we can now take a look at examples that involve the 30, 60, 90 right triangles. Here's the question. The question is, let's find the values of x and y and give our answer in simplest radical form. Well, check this out. Here I see this angle is a right angle, and I see this is 60 and this is 30. So that means this is a 30, 60, 90 right triangle. That's great. Y is the hypotenuse, x is the height here, and so let's see if we can figure this out. Well, if I know that that this is x, then to draw it in the way that my picture is, by the way, I should kind of tilt it like this. You see, now it's perfect. 60, 30, 60, 30, and right. And so this might actually help us a little bit to think about it, because what I see here is if I know this is 8, then this must in fact be 8 divided by the square root of 3. Just as we see that this is A, this is the square root of 3A. So what I see here is that x, let me actually pull it back the way we had it so it won't be so crazy. X is going to be 8 divided by the square root of 3. Really? Well, sure, because check it out. If I call that A, then to get W, I've got to multiply A by the square root of 3. When I multiply it by the square root of 3, the square roots of 3 cancel. I'm left with just 8, which is what we have here. So that checks. Now, of course, we like to rationalize the denominator for traditional reasons, and so I see 8 square root of 3 all over 3. And so that's x. And so that's going to be actually 8 square root of 3 over 3 in simplest form. What about this hypotenuse? Well, we've already seen that the hypotenuse is twice the shorter side length, and so it's just going to be twice this. And so therefore y is going to be this times 2, which is 16, square root of 3, all divided by 3. Not a problem. Let's try another one together. Again, if we just think through these things, we're pretty much good to go. Here we see a 30, 60, 90 right triangle. The hypotenuse is 14. That corresponds to this. So the short side, the side opposite the 30, is going to be half of the hypotenuse. So without any work at all, I see this is going to be half of 14, which is 7. Once I know the 7, how do I get this height? Well, that's the square root of 3 times 7. So this is just 7 square root of 3. Easy as that. The 30, 60, 90 right triangle. Another golden oldie.